Hello everyone and welcome back to the channel. Today in this video I'm going to be showing you guys how to build yourself a desktop computer. Now this video is going to be made with the intent to show those who have no idea how to build a PC, whether it's just understanding what the components do, the terminology, and just generally what a computer does. I will be explaining things in the easiest way possible so that someone who has no idea how to build a computer can understand how to make one without being overwhelmed with too much information. Now, building a PC is really easy to do. You get to save some money, or a lot. You get to choose the parts yourself, and future upgradability is a great thing to have because if you want to upgrade down the road, you get to choose that specific part without having to upgrade your entire computer. So this video is going to be broken up in 3 parts: understanding the components, choosing the parts, and then building it. In this video, I will talk to you guys about what each one of the components do so that way you get an understanding on how to choose your parts wisely and then assembling it down the line. So without wasting any more time, let's check it out. Okay, so I will discuss what each of the parts are in order so you know what we are dealing with. So first, let's start with the motherboard. The motherboard is the piece that holds everything together, binding all of the components to communicate with each other to do a given task. It is almost like a manager, separating and organizing everything so that the other parts don't just behave on their own. Next is the CPU, or Central Processing Unit. This little guy is responsible for doing every technical thing you do on your computer. Whether it is moving your mouse on the screen or rendering a clip on a video editor, the CPU processes every command you give to the computer. Now onto RAM, or Random Access Memory. These sticks are responsible for allowing you to do multiple things at once. Typically when you download a game or a program, they usually list how much RAM you would need to run the program smoothly. An easy way to remember is the more RAM you have, the more you can do. The less you have, the less you are able to do. Now onto storage. These devices carry all of the information your computer has. All of it. From a simple text document to the entire operating system you are using. There are 2 types of storage. The first one being hard drives and the second being solid state drives, or SSDs for short. Hard drives are known for their large capacities and cheap price, but struggle greatly with speed. SSDs, on the other hand, are known for their blazing fast speeds, but with the trade-off being lower capacities and a higher price tag. Next up is the graphics card, or GPU for short. These beasts are responsible for processing all of the graphic-intensive tasks your computer uses. GPUs often handle workloads like games, video editing, and 3D images. The next part is the power supply, or PSU for short. This brick manages all of the incoming electricity from your wall outlet and distributes them to your components, similar to how a car battery provides power to your vehicle. And the last part of the PC is the case. This pretty much houses everything together, whether it is for performance or aesthetic purposes. Now that I have finished talking about what each one of the components are, now we can start focusing on what the variations are. So like the type, the sizes, and also the performance differences among each one of the components. So let us start with the motherboard. For the motherboard, there are a few different sizes, but the 3 most common ones are ATX, Micro ATX, and Mini ITX. An ATX motherboard is the, what we can say standard or regular size for computers to use. Some are able to hold more than one graphics card, drive more electricity to work with more powerful components, and other miscellaneous connections. A Micro ATX board behaves very similar to an ATX board, however with one key difference, which is in the name, that the board is a bit smaller. Micro ATX has all of the common features as an ATX, but with fewer features to work with. These boards are commonly used for people who just want a PC that works without all the extra features. The last board to talk about is Mini ITX, very similar to like the other ones, but with the size being a little bit smaller, as the name implies. This board is convenient for those who want to build a PC in a very small form factor. Moving on to the CPU, there has not been that many changes in physical size recently, but there are a few performance differences. The two main brands right now are AMD and Intel, both producing different types of processors. Let us start with Intel. They have released many processors for all kinds of workloads, but just to keep things simple in this video, we will be only looking at 3. Those CPUs are the Core i3, the Core i5, and the most popular for advertisement, the Core i7. As for AMD, we will be comparing the Ryzen 3, Ryzen 5, and Ryzen 7. Starting with the Core i3 and Ryzen 3, these chips are considered the lower tier in PCs. It is able to handle light CPU based tasks like web browsing, office work, and maybe some light gaming. The Core i5 and Ryzen 5 on the other hand are mid tiers, in which they allow for smooth gaming sessions and also to do some light productivity. Stepping up to the big boys on the top tier are the Core i7 and Ryzen 7. These CPUs have a decent performance boost over the mid tier, making this chip ideal for people who use CPU intensive tasks like video editing, 3D graphics, and gaming at very high resolutions. Moving on to the RAM, and here's where things get interesting. What brand you choose is pretty much up to you, but the important thing that you have to keep in mind is speed and capacity. How much RAM you need can vary. If you're an average user who is just on the internet, edits documents, I think 8 GB is enough. Gamers should be looking at around 16 GB considering how graphically intensive the latest titles have become, and lastly, productivity users should be at 16 or higher, but depending on how much work you actually have. The speed of the RAM is where things get a bit confusing for some, so in plain English, faster RAM will allow you to do more tasks efficiently, but only when used in the right applications. I will go further in depth on the next video. For storage, some components come in different shapes and speeds. The standard sizes for drives are 3.5 inch, 2.5 inch, and an M.2 interface. Let's start with the 3.5 inch. This size is the most common for desktops since there is plenty of room to work with. 2.5 inch is the size for SSDs typically, and even though hard drives can be made in this size, however you will be sacrificing a lot of performance and longevity due to that small form factor. An M.2 interface uses similar if not the same technology as an SSD, but instead of it being mounted on your computer, it goes directly onto the motherboard. This technically allows for less cables, cleaner interface, and, depending on the model, much faster performance. Now onto the graphics card. And before I begin, since there are so many models and brands out there with different purposes, I will simply break it down in categories for different use cases, similar to how I broke down the processors. There are 2 use cases for adding a GPU in your PC. It is either for gaming or productivity. For gamers, there are usually tiers of cards to choose from depending on the kinds of games you would like to play and at the type of resolution you wish to play at. For productivity, the tiers are similar, but you would pretty much go for the one that you can afford and think is the best suited for the tasks you wish to throw at it. Now, there's a lot more information to talk about, so I will discuss more about this on the next video. Moving on to the power supply, there are only 2 sizes and 3 variations for them. For size, there are only ATX and SFX power supplies. An ATX is the standard size for regular sized desktops, while SFX is the smaller version of an ATX, simply designed to physically fit inside a small form factor PC. And as for the variations, there is non-modular, semi-modular, and fully modular. Non-modular means that you cannot disconnect any of the cables coming out of the power supply. Semi-modular allows you to disconnect some, but not the major ones your computer needs. Fully modular allows you to disconnect all the cables and use only the ones you wish to use. Last thing on our list are PC cases, which is the best part of building because you get to choose how it looks. There are many sizes to choose from, but every case corresponds to the motherboard and power supply you have. Just like motherboards have their standard names, cases follow the same trend as well: ATX, micro ATX, and etc. The size usually indicates what motherboard or boards are supported, but there are other variations. For example, there are Micro ATX Mini Tower, Micro ATX Full Tower, ATX Super Tower, and so on, with slightly different but easy to understand names. And that is it for part 1 on how to build a PC. I hope that this video was really helpful and easy for you guys to understand. On the next part, I will be showing you guys how I assemble my parts together, how I choose them precisely based off whatever need that I have, and also the tools I use to narrow down my results. Anyways, that is it for today, guys. If you found it helpful, please leave a thumbs up and subscribe down below if you want to see more future content like this and even the next 2 parts that are going to come up soon. Anyways, guys, thank you for watching. See you guys next time.